React, functional component state. Why do we care about state? Components take care of themselves. This means that each functional component must keep track of any data it uses. In React terms, this is its state. However, there's a problem. We can't just change data whenever we want. React controls all of the components. Remember, it processes the JSX, converts the XML into JavaScript, and then uses the JavaScript to run stuff. We don't really have control about any. We really don't have much control over that process. It just does it automatically. So if we want React to keep track of data, we need our components to keep track of states. And again, we remember components take care of themselves. So this is good. So components have state and they can keep track of their own data, which again is within components taking care of themselves. So we can't change things, but React can. But remember, we're talking about functions for functional components. So they don't have methods. They don't inherit from component, which means they cannot access setState. It doesn't exist because it only exists as part of component. There's also no this.state2update. So we would seem to be in a weird situation. Well, React knows about this, so React has a new function we can import called useState. Notice this is just slightly different than setState. setState is for class components, useState will be for function or functional components. So it's a little bit weird, but it accepts an initial value, and then it provides an array with a variable and a function to change that value. So the output of useState is an array. However, it expects something interesting. It expects the developer to understand destructuring assignment, which is a feature of JavaScript EX6. We can break apart a structure, destructuring is part of this definition, such as an array or an object into its component parts, which is to say, we can take an array and break it up, or take an object and break it up as well. And we see an example of that right here. This looks incredibly strange because we see open and closing square brackets on the left-hand side of an assignment operation. But what we're doing is we are destructuring what useState returns. useState returns an array where the first entry is a variable and the second entry is a function to change that variable. So we see here let example would be the first value within an array, and change example as a function to then change that variable. So again, we're setting up a state within a functional component. So let's look at an example of that within Visual Studio Code to make sense of these different concepts. So I'm going to move over to Visual Studio Code. And we see some example code here using a function called app, which makes it, of course, a functional component. So we want to introduce state to this functional component. Well, remember, this is not a class component, so we're not importing component. But React provides an additional function called useState instead of setState for class components. So if we're going to import something else from React, we add a comma, and then we want to import something from this. So in this case, use, and look, it's already starting to guess, state. So we're going to import React, because we always need React to queue React in that this file contains JSX and needs to be parsed, and use state. So right here, the functional component is a function. So it's going to return something right here, lines 8 through 14 currently. Above that, though, I can define a destructuring assignment. So let example is equal to change example is equal to use state, and then the initial value of a variable I want to keep track of. So I'm going to give it an initial value of 0. So now I've created here a state where it is set equal to the variable example. And notice it says, hey, this is declared but never used. And we're going to use it here in just a moment. But from now on, after I've established this here in line 6, I can use example because it's now part of the state, anytime I want to change the value of example, instead of just changing it by myself, I instead supply a new value to this function right here, change example, which will change the example using something that's defined within state as part of React. Which again is a little bit confusing, but think of it as here's the value, here's the thing we use to change the value, right? The value and the mutator, or the thing we use to change it. So in order to change this though, we're going to have to think a little bit about how, excuse me, a little bit how attributes and elements work, and especially events. So as a reminder of JavaScript events, we can place a listener, a event listener on an element by using the on syntax. So if I want to listen for on click, I can write it like that. And if we were using JavaScript in another setting, perhaps in a browser, we might in quotations put the function we want to call. But this is JSX, and we can't use quotations unless we want an exact value. Instead, we use it like this to put in expressions. So what do I want here? I want on click. When an on click happens, I want it to call an arrow function that calls change example. What should change example do? It should take the current value, example, and it should add 1 to it. So what I want to happen is every time I click this button, the current value of example is increased by 1, which is given to change example, which will change the variable example. So again, it seems a little bit convoluted, but because this is working within the same function, we're actually keeping track of the data outside of it using useState, right? It returned a function which is taking care of everything for us. So I need to close this, which is what it reminded me of. And I'm going to say increase. Okay, so we've added a button. So I'm going to add something right here where I want to see the current value of this counter. So I'm going to say count, and the current value is example. So again, we access the current value in example, and we change the current value using its mutator, or in this case, change example. So I'm going to save this, and notice it compiled successfully, told me down here. So I'm going to move over to Firefox, and we see count 0, which is of course the value of example, and if I click increase, it changes it each time. Okay, through 17 clicks in this case. So let's go back to this code and walk through this again, because it's a little bit complicated. So this is a functional component, which means we don't have access to the normal methods we would use within a class component, which is to say we don't have access to setState, because that's part of component, which is a parent class. So no class stuff right now. So instead, React provides useState, which is a function we can use. We import useState by using curly brackets and, of course, useState within that. So notice right here, if I put a cursor over it, it says returns a stateful value and a function to update it. So right here, I supply an initial value to useState. It then supplies back an array. The first entry in that array is the value of the thing I gave it initially, and the second one is a function to change that value. So in this case, I supplied the value 0. So initially, example would be 0, and change example, whatever I supplied to it, would change the value of example. Now again, you may be thinking, why don't we just change example right here? Well, we could do that. The problem is, remember, this is a functional component. So it is being re-rendered, being called. Every time it does that, then it would change the value of example and reset it. So we use useState as a function defined outside of this, as part of React, in fact, to keep track of that for us. So it keeps track of the state outside of this function. So we then use the current value here, example, right here as an expression, and we defined an event on click. So every time I click this button, it calls an arrow function who, right here, calls change example right here that changes this value. I supply it with a new value, example plus 1. It could in fact be anything, and it will increase each time. So again, example is the current value, no matter the loop, because it's kept track of outside of this, and change example is the function we use to keep track of or change that state, that is. So we have the current value, and we have a way to change that value. Now, again, something else I want to highlight here, if we wanted multiple values, as we might have within a class component, we would have to use state for those values per value. So use state only creates a stateful value for one value. So if I wanted to keep track of a counter and something else, and something else, I would need multiple calls of useState and then create for each of these a new value and a new mutator or a new function to change those values per value I had. So again, it's useful here, but you would need multiple calls for it if we were tracking a whole bunch of stuff. So again, reviewing everything I've talked about. Components take care of themselves. Any data a component has is called its state. This is how React calls it. Because this is a functional component, it does not have access to methods because methods are part of classes. So we use the function called useState to create a stateful variable within a function component. We supply an initial value to useState and then use the destructuring assignment, which is part of JavaScript EX6, to break apart the thing it gives us into the variable or the current value and a thing to change that value, usually in this case a function. So in this code right here, we have example, which is the value, and the thing we use to change example, I've called change example. So very helpfully here. So very common use case would be with an event, in this case an onClick event, which I've used onClick as an attribute within the button element. It has as its value, again values are within these expressions here, arrow function, and within this calls change example, takes the current value, example, and increases it by 1. So we could, as one final thing, change this to 3, save this file. Notice it recompiled successfully. I will go back to Firefox. And we could have it increase by 3 each time. But notice it keeps track of all of those values outside of this code using useState. So a little bit complicated in different concepts, but coming together here to show how we can create state in functional components.